In this video, the focus is on understanding factor theorem with respect to polynomials. What is the application of factor theorem? How will we use to check whether a certain linear factor is a factor or not? So now let's get started. Let me take the example of 6 divided by 2. 2 into 3 gives you 6, leaves a remainder of 0. In other words, 2 is a factor of 6. On the other hand, if I want to divide 7 by 2, 2 3s are 6, that leaves a remainder of 1. Since the remainder does not equal to 0, therefore 2 is not a factor of 7. So it's a simple example of arithmetic which gives an idea, a little insight of what factors are all about. If I apply this concept to a polynomial, and if I say if fx is a polynomial, an algebraic expression with many terms in which the powers are in integers. If fx is a polynomial and fx is being divided by x minus a, which we term as a linear factor, and f of a gives us 0. What does it mean? It means that x minus a is a linear factor. Let's get started with this simple example. Let me take a quadratic expression. For example, fx equals to x squared plus 5x plus 6. Can I factorize it? Definitely yes. That is x squared plus 2x plus 3x plus 6. That is x plus 2 plus 3x plus 2, and this simplifies to x plus 2, x plus 3. Now, I have broken down a quadratic expression into its linear factors. If I say let fx equals to 0, x squared plus 5x plus 6 equals to 0, x plus 2, x plus 3 equals to 0, therefore x is equals to negative 2, therefore x is equals to negative 3. These are the roots of the equation. Fx equals to 0. These are the solutions of equation. These are the x-intercepts because that's where the graph cuts the x-axis. So now if I write this thing and if I want to check that fx is a polynomial x squared plus 5x plus 6, and I want to check is fx divisible by x plus 2, I'm not sure. Let me check. So I'll plug in f of minus 2. Therefore, minus 2 whole square, 5 into minus 2 plus 6, which is 4, minus 10 plus 6. This adds up to 0. I already knew it that x plus 2 is a linear factor. I just want to apply the concept of factor theorem. Since f of negative 2 equals to 0, in other words, x plus 2 is a linear factor. Similarly, if I apply the concept and if I say fx is still x squared plus 5x plus 6, is it divisible by x plus 3? What should I plug in? Basically, I'm taking this x plus 3, I'm equaling it to 0, I get the plug-in value. The plug-in value is negative 3. F of negative 3 is negative 3 whole square plus 5 into negative 3 plus 6. That is 9 minus 15 plus 6. That comes out to be 0. Yes, we have double confirmed that x plus 3 is again a linear factor. Now, do you think there are other linear factors? I don't think so. If x is x squared plus 5x plus 6, can it be divided completely by x plus 1? Let me plug in. F of minus 1, that is minus 1 whole square, plus 5 into negative 1 plus 6. This is 1 minus 5 plus 6. 7 minus 5 is 2. Since f of negative 1 does not equal to 0, therefore, what's the conclusion? X plus 1 is not a factor. So that's the conclusion that we have drawn. So this is the basics of factor theorem. Now, let's look at a question, something like more of an exam type question. Let me call this thing as worked example 1. There is a polynomial fx and it's given as 4x power 4 minus 3x squared plus a, where a is an unknown constant. So the unknown constant is a and our objective is to find a. What other piece of info is given? It's given that x plus 1 is a factor. Find a. So since x plus 1 is a factor, what is the plug-in value? So the plug-in value is x plus 1 equals to 0. Therefore, x is negative 1. If I plug in negative 1 in fx, and since it's a factor, f of negative 1 should equal to 0. So 4 into minus 1 raised to power of 4. And this is negative 3. Negative 1 square plus a should equal to 0. That's 4. Minus 3 plus a equals to 0. 1 plus a equals to 0. In other words, a comes out to be negative 1. So that's how we apply the concept of factor theorem in order to solve a question which involves one unknown constant. Let's try out one more question. Something like fx is given as px cube plus qx square minus 3x minus 7. Now you can see for yourself, there are two unknown constants. So technically, this will be a question involving simultaneous equations. What other piece of info is given? Given that x squared minus 1 is a quadratic factor, evaluate p and q. Now we know that factor theorem is only applicable for a linear factor. The plug-in value is obtained from a linear factor, but this time this is a quadratic factor. So the rule is first factorize the quadratic factor. X squared minus 1 becomes x plus 1, x minus 1. So we now have two linear factors. So basically, the question now becomes that f of something should equal to 0. F of something else should also equals to 0. If I focus on the first bracket, the plug-in value is x plus 1 equals to 0, x is negative 1. If I focus on the second bracket, x minus 1 equals to 0, therefore x is 1. So now I'll be forming two equations and I'll be solving them out for finding the value of p and the value of q. So our fx is fx equals to px cube plus qx square negative 3x negative 7. First equation, f of negative 1 equals to 0, p into negative 1 cube, q into negative 1 square, negative 3 into negative 1 minus 7 equals to 0. Negative p, positive q, positive 3, negative 7 equals to 0. negative p plus q minus 4 equals to 0. Therefore, negative p plus q equals to 4. This is equation number 1. Similarly, applying the second condition, f of 1 equals to 0. So therefore, p of 1 cube and q of 1 square, negative 3 into 1, negative 7 equals to 0. P plus q negative 3, negative 7, which adds up to negative 10 equals to 0. Therefore, p plus q equals to 10. That is equation number 2. Simple equations which can easily be solved using the process of elimination. P plus q equals to 10 minus p plus q equals to 4. Add up both the equations. What do we get? 2q equals to 14. Therefore, q comes out to be 7. Similarly, p plus 7 equals to 10. I'm using this particular equation, which is equation 2. And p is equals to 3. So therefore, the value of p comes out to be 3. The value of q comes out to be 7. In other words, the polynomial was p is 3, which is 3x cubed plus 7x squared minus 3x minus 7. And that's how factor theorem is used in questions which relate to polynomials.